I'm Tianma from University of Electronics Science and Technology of China. I'm happy to be here to present our work, Klonet, an easy-to-use and scalable platform for computer networks education. This is a joint work by University of Electronics Science and Technology of China, Huawei, Southwest Minzu University, and Zhongguancun Laboratory. As a gateway into the world of computer networking, education plays an important role in shaping the future of the computer networking community. As we know, one of the unique challenges of computer network education is the need to engage students in extensive hands-on practice to deepen their understanding of abstract concepts in textbooks. There are three ways for students to get practice. The first choice is testbed, which enables students to interact realistically with computer networks, but is expensive. For example, students can run real applications on real devices. One can also choose simulator, which is driven by discrete events. It's cheap, but not realistic enough. As a compromise between the two options, emulator runs real applications on virtual net devices, providing realistic interaction while being cheaper. Therefore, we aim to build a network emulation platform for education. We know that the first step is always the hardest. When using traditional platforms, students often spend so much time learning the platform's operation that they are unable to focus on learning the computer network itself. Tutors also have a lot more workload due to the introduction of the platform. Thus, an ideal education platform should be easy to use. It should help students lower the barrier to use and improve tutors' teaching efficiency. An education platform should also be scalable, which means it should be able to support many students doing experiments together at the same time and support large simulation network sizes. Existing emulators can be divided into general purpose and education purpose emulators, and they have made excellent contributions, but still cannot achieve the above two design goals. Minnet is a representative general-purpose emulator. When using for education, students need to manually install it, which is hard, especially for those beginners. Installing Minnet on a shared server sounds like a good idea. However, Minnet is not suitable for multi-students since its poor isolation and scalability. Besides, Minnet lacks a user-friendly GUI, which is quite critical in the education context. EmuLab is another famous emulator, but it is a heavyweight, poor scalability, and slow, making it not meet the design goals. There are various emulators that simplify the topology to focus on end-to-end network properties. These emulators cannot emulate devices such as routers, limiting their application in education. Some emulators are designed for special scenarios, and they lack support for other scenarios. For example, StarryNet only focuses on emulates the integrity space and terrestrial networks. There are also some education purpose emulators. However, they have limitations such as heavyweight installation required and poor scalability. To summarize, the existing network emulators still have limitations in terms of easy to use and scalability. We argue that no existing emulator can achieve the two educational goals simultaneously. This motivates us to design Klonet to meet these goals at the same time. Let's take a deeper look at Klonet. Klonet adopts a layered architecture, which can be divided into experiment layer, control layer, virtual network layer, and infrastructure layer. Klonet is a shared platform built on a cluster to provide experiments as a service. Students and tutors can use it via its website. Klonet supports network experiments from layer 2 to layer 7, and it supports network scenarios such as data center networks and campus networks. Users can customize their topology in Klonet. Klonet allows a mixture of real and virtual devices. It supports rich node types such as host switches and routers. Now, let's uncover the design details behind Klonet and how they align with the two educational objectives. To achieve easy to use, Klonet first adopts a browser-server architecture which could save students from tedious installation steps. Students can use Klonet directly via their browsers. Users can use Klonet via a web GUI or experiment API, which is easy to use and well documented. Note that, unlike research-oriented platforms, a well-designed GUI is important in education-oriented platforms. Klonet builds an image repository and C repository for students and tutors. Based on these repositories, diverse network scenes can be established. Students can share their experiments and learn from each other, and tutors can set up the experiment environments quickly and grade the experiments more efficiently. Klonet also provides some useful tools, such as traffic generator, traffic monitor, and typical topology generator. These tools allow students to focus more on learning about computer networks rather than spending efforts on other tools. The speed of experiment creation has a serious impact on user experience and efficiency. Therefore, Klonet uses two parallelization technologies to speed up the creation of experiments. In terms of scalability, Klonet designs and implements a distributed orchestrator on the Klonet cluster that includes a controller and several agents. The controller can assign tasks to specific agents for execution. Blindly mapping virtual networks on the cluster may cause some servers to be overloaded, which in turn causes a loss of fidelity in the experimental results. To tackle with this problem, Klonet designs a heuristic virtual network mapping algorithm to deploy as many virtual networks as possible without overloading servers. As a shared platform, Klonet should be able to organize multi-user and multi-experiment data. To achieve this, Klonet implements a user-managed model based on the Redis database. To increase the number of virtual networks that can be supported on each physical server, Klonet employs lightweight virtualization technologies such as Docker containers and virtual Ethernet pair to reduce resource overheads. For a shared education platform which provides experiments services, robustness plays a significant role in guaranteeing a smooth education process. Klonet achieves its robustness from top to bottom. Please see more details in our paper. We conduct an evaluation to test the fidelity of Klonet with multiple students. Specifically, we run multiple flows with the same preset throughput at the same time to simulate the process of multiple students doing the experiments at the same time. The experimental results show that as the number of students grows, the sum of the Klonet throughput grows linearly and is the same across flows, which means that Klonet maintains scalability while the experimental results remain accurate. Therefore, we believe that Klonet can support more students to do experiments at the same time. For virtual network creation time, we compare Klonet with two representative platforms, MLab and DistrictNet. The results show that Klonet has a faster speed to deploy virtual networks. We also evaluate the proposed virtual network embedding algorithm. we simulated the process of mapping a virtual network to 10 physical servers, and if the resource requirements of the virtual network are not met, then its deployment is considered a failure. From the simulation result, we can see that Klonet has a more efficient virtual network embedding algorithm. It can support more virtual networks in the same cluster without overloading them. Klonet has been used in many courses and even in research works such as programmable network experiments, virtual real hybrid networking experiments, and network configuration experiments. It has served more than 800 students in the 2 years of operation. Next, let's dive into the playing with algorithm project and the intra-domain routing project. The purpose of the playing algorithm project is to provide students with a deeper understanding of the performance of the classical shortest path computation algorithm through programmable networks. We expect that at the end of program, students will be familiar with OpenFlow and be able to successfully validate the performance of their algorithms. Using traditional platforms, the following challenges may arise. First, for students, how to focus on learning SD networks rather than building them. Second, how to quickly replay experiments for self-improvement or tutor assessment. Third, how to interact with the network, control it, and observe its performance. With Klonet, these challenges can be well addressed. Using the image repository of Klonet, tutors can quickly set up experiment environments for students. With the C repository, students can quickly load and upload experiments, and tutors can conveniently create experiments. Using Klonet's web terminal and SSH connection, students can easily operate and observe the network. Through this use case, we show that Klonet is easy to use in education. The intra-domain routing project is designed to give students operational experience with enterprise networks. The learning outcomes we expect are that students can experience the impact of different OSPF configuration policies in a large-scale network. Klonet is used to address the following challenges. First, the enterprise-level network requires the education platform to be highly scalable. Second, the enterprise network requires complicated configuration. Third, it is hard to observe the enterprise network. Students collaborated with each other to achieve routing and eventually summarized the results of their experiments in this figure, which shows the relationship between convergence time and the network time for different OSPF configurations. Note that the size of the network eventually reached close to 10,000. This use case shows that Klonet is able to achieve great scalability while maintaining configurability and observability. As a conclusion, we present Klonet, an easy-to-use and scalable platform for computer networks education. Up to now, Klonet has been in development for 4 years and in operation for 2 years. And it has been used in 3 universities and 4 courses, serving more than 800 students. Finally, we hope more attention to be invested in computer networks education to bring more people into our community. Thanks for listening, and please feel free to contact us for any discussion or cooperation. I appreciate any incoming questions from you.